let's talk about what is the process to solve a mass balance problem. So this is your formula, your set of steps for solving every single type of mass balance problem. The first thing that you need to do is figure out the type of problem. Is it continuous or batch, steady state or transient? Once you know that information, you have a procedure. So for the first example here, we are going to look at balances on continuous steady state processes. This is the most common that you will ever see in environmental engineering. If we are steady state, remember accumulation will equal 0. So the mass balance simplifies to input plus generation equals output minus consumption. If the balance is on a non-reactive species on total mass, we can further simplify by saying generation is 0 and consumption is 0. Therefore, the input must equal the output. Now, why is this the case, right? Conservation of mass and conservation of energy. If we're conserving mass, all the transfers of energy and matter that move throughout the process must be constant over time because mass cannot be created or destroyed. So neither quantity can be added nor removed. Mass quantity must be conserved with time. That is the law of conservation of mass. If you end up with more mass than you started with, generation or consumption had to occur in a specific species, but the total mass, right? You can't have a change in total mass. That's critical. The other one is the law of conservation of energy. The total energy of an isolated system is constant. It's conserved over time. And this is going to be more and more important as we get into energy balances. So remember that steady state or continuous means that values do not change with time. So if they do not change with time, then we have something that we can simplify a little bit more. Okay? So if we have a continuous steady state process with non-reactive species, the balance should simplify to input equals output. If it does not, we need to take a look back at the problem. We can also have batch processes, right? So by definition, in a batch process, the accumulation is the final output minus the initial input, and the accumulation can be thought of as the generation minus the consumption. So therefore, in a batch process, we can always say that the initial input plus the generation is equal to the final output plus the consumption. So we are talking about the entire system right now, not individual species, the entire system, right? So what comes in must come out in terms of total mass in a batch system. That's what's happening here. Now you can imagine if the generation and consumption also equals 0, then your input, your initial input, must equal your final output. Last, a semi-batch system. What we do in a semi-batch system is slightly different because remember it's a weird case. We write a differential balance on the system. We start with the initial general balance equation, right? Input, output, generation, consumption, accumulation, all 5 terms. And then once we have a differential balance, we integrate with respect to time because we are looking for a specific thing that happened in the semi-batch system. That's it for semi-batch. We really don't see these this semester. They're very rare in some of the problems that we solve in an ideal world. They do exist in the real world, so it's not that they don't exist. All right, so that's the procedure for each of these different types of processes.